So this is the first slide. It includes introduction to computers and Java programming language. So if I want to teach students how to program, we need to also let the students learn some concepts, mafahim. I cannot just go directly to the programming language without introducing what does it mean by high-level language. What does it mean by machine language? What does it mean by a compiler? So these are concepts that students should learn before they start learning any programming language. So this is the theory part. First, we need to make a difference between hardware and software. So the picture you see in front of you are part of a hardware. So any physical component that you can, it is tangible, malmous, it's part of a hardware. Even the wires, the wire is part of a hardware. Now, this picture in the middle is the computer. Inside the computer, it has 3 units. The first unit is the central processing unit. For short, it is called CPU. All the calculations are done here. So this is why sometimes it is called the brain of the computer. So any program you write, this part will execute it for you. ينفذه, okay? It will run it on this part. In addition to this, the brain cannot work without memory. So the second unit is the memory unit. Any program you want to write, you have to keep it in the memory so that the CPU can take it from the memory. So the central processing unit do the calculations, but it has to take the instructions, التعليمات, from the memory, your program. So the program should be in the memory. So we have a memory unit. Again, for the memory, it is a hierarchy. It's not only one type of memory, there are many types of memory. The one that is close to the CPU is the main memory, الذاكرة الرئيسية. And it is usually called RAM, Random Access Memory. This memory is very fast and it is made of electronic circuits. So see chips. This is why they made it with chips. They want to make it faster when the CPU wants to communicate with the memory. Other than main memory, there are secondary memory, which are memories outside the main memory. And by the way, there are again 2 types of main memory. I forgot to mention this. There is RAM, random access memory. There is ROM, read-only memory. The difference between the two, RAM, when you put data inside it and you turn off the power, no electricity, everything is lost. ROM, which is read-only memory, is different. When you put data on it, when you cut the power on it, still the data is inside. An example is the flash. If you have a flash memory, and if you put data inside, and when you turn off the power, when you unplug it from your computer, then there is no electricity, but still the data is inside. So the type of memory inside is read-only memory. But for the main memory, usually they use RAM. So when you switch system, iOS is loaded into the memory, and then the computer will start, the CPU will start taking the instruction. The other memory, which is called secondary memory, usually some of them are built inside the computer and some of them are located outside. So the secondary memory, as you see the picture, one of them is the hard drive. The abbreviation for it is HDD, hard drive. But this hard drive is made of magnetic. You know, see magnetic disk? So this is why the magnetic disk, the hard drive, is slower than the main memory, which is made of electronic circuits. So sometimes when you buy a computer and it is made of, and it is installed with HDD, when you load the when you start the computer, the loading is slow. Why? Because see the arm inside, while it is moving, it takes time for the data to be moving around the magnetic disks. Nowadays, there are new types of hard drives. They are not made by magnetic disks, they are made by electronic circuits like these, and they are abbreviated by SSD. So when you go and buy a computer a laptop, for example, check for the hard drive, which type. Is it HDD or SSD? And usually if the hard drive was SSD, it is expensive, but it makes the computer maybe 80% faster, especially when on loading. So nowadays, all new computers that are made with SSD hard drives. Your mobile, for example, your mobile inside, it has both of these memories. Main memory made of electronic circuits, and also it has a hard drive inside, which is called secondary memory. And this is the one that usually used for advertising. When you say my iPhone is 256 GB, my Samsung is, let's say, for example, 128 GB. But it is not made of magnet. It is made of electronic circuits, like a flash drive. This is why you don't hear a sound. And this is why they made it of electronic circuits, because the mobile should be fast for getting the data. So if you want to buy a computer, just look for this type of hard drive. It should be SSD, is better than HDD. Also, there is DVDs are secondary memory, and flash are also secondary memories, and etc. Now, any device gives information to the computer will be considered as input device, and any device receives data from the computer will be output device. For example, the screen. The computer shows the data on the screen, so the screen is output. And for example, the keyboard. When you press on the keyboard, the data goes to the computer, so it is input. The camera put pictures on the computer, so it is input. So we have input devices and we have output devices. The mouse is not here. Is it input or output?
Input.
It should be input. Why? Because it gives data to the computer. So a hardware includes tangible parts of computer systems, and softwares will be the programs. You are all familiar with your mobiles. The mobile itself, the screen, the components inside are part of hardware. But the software, for example, Android or iOS for iPhone, these are, and the programs that you install on your mobile, they are all software because they are programs. So if you get familiar with your hardware, this will help you to understand your software. For example, if you want to put a software, Windows 10, on your computer, then you need to know the hardware. Do you think that your computer can handle Windows 10? Is it going to be slow? Is it going to be fast? So understanding the hardware will help you to understand your software. As I mentioned before, the computers include input devices, output devices, and a processor. A processor is the CPU. So the central processing unit is the processor. As I mentioned, also two kinds of memory available, main memory and auxiliary memory. Auxiliary, it means secondary, ثانوي. Anything other than main memory will be auxiliary. Flash, DVD, any media you can save on it, then it will be auxiliary memory. Now for the processor, which is the CPU, it processes programs instructions. As I mentioned, that the program will be put in the memory and the CPU will take those instructions, التعليمات, one by one and executes them. When we say execute, it means تنفيذ, okay? Make them يعني following, okay? It can process only very simple instructions. So it cannot handle complicated instructions, as we will explain later, that programming languages are either high level or low level. So it can only process low level instructions, small instructions. So the power of computing, either programs or hardware, depends on the speed and the complexity of your program. So when your program is complicated, then it will be slow, and if it is easy but for the hardware, it will be faster. Here is about the memory. The purpose of the memory is to hold programs, data, and some results. So it's a place to keep data. مكان لحفظ المعلومات. There are two types, as I already mentioned: main, which is inside the main board of the computer, and auxiliary, which is outside the main board. So the working memory is used to store the following: programs, data, and results. And the unit that is used for measuring the memory is bytes. So when you buy a mobile and they say that the memory is 20 GB. So what is GB? GB stands for gigabyte. So what is a byte? So a byte is a unit for storage. وحدة تخزين in the memory. If someone tells you how much data do you have in this memory, so the unit used is byte. It's like for metric measurements. If someone tells you how long is this table, what is the width and height of this table, then you have to give a measurement unit that all people understand for length. For example, foot, or for example, meter, centimeter, inch, and etc. So the unit that is used for memories is byte. So again, we have to ask ourselves, what is a byte? A byte is the quantity used for memory, but what is exactly is the byte? Let us finish first the type of auxiliary memory, and then we will go explain to you what is a byte. Auxiliary memory, it means secondary memory. Type of secondary memory: CDs, DVDs, flash drives, and usually they are non-volatile. When we say non-volatile, it means when you put data in it and you cut the power, still the data stays inside the memory. Volatile, it means if you cut the power, everything is lost. And they are usually measured in bytes, okay? Gigabytes for large numbers. So what is a byte? Computers usually don't, usually they are made of electronic circuits. And computers deal with numbers for their calculations. A bit is part of a digital signal. So there are analog signals and there are digital signals. When you have an electronic circuit, everything inside the circuit is electricity, and the components are electronic components. So this electricity, if we want to convert them or deal with numbers, then we have to make the signal levels for numbers. So we are, as a human being, our numbers consist of 10 digits: 0, 1, 2, 3, and etc. So for the signal that goes inside the electronic component should be divided into 10. But if this happens, then the circuits will be very, very, very complicated. So they say, why we should deal with 10 digits? We are not, the computer is not a human. So how about we design the computer so that can deals with signals that we can divide them into only 2, either 0 or 1. And we can have any number for us as a human converted into these 2 digits. So for example, if I have the number 123, it is easy to convert it into 0 and 1 because 0 and 1 is a different numbering system. So when you design circuits with only 2 levels, the signals with only 2 levels, then the design is much simpler. There is a whole course in the computer engineering. It's called digital design. They teach the students how to design circuits, digital circuits. So when we say a bit, it's a signal that consists of either 0 or 1. You know that components are connected by sometimes wires, sometimes by small wires on the electronic board. The signal that goes inside has 2 levels, either 0 volt or 1 volt. not 1 volt, 5 volt. So 5 volt is represented by 1 and the ground is represented by 0. Okay, so I'm going to draw by the mouse. Usually if this is the signal, so this is the time, here we have the time, and here we have the voltage. So this is time, and here we have the voltage. And the value for the voltage will be 5 volt. Okay. So when we have an analog signal, then the signal will look like the following. I have to draw it somewhere else. Looks like something like this. So as you see that there is no one level for the signal over the time. But for digital signals, we can have it as follows. This is a digital signal. So we have two values for any time. Either, so at this point here, the value for the signal is 5. But here, the signal is 0. So this is, we say 1 because 5 volt. And here we say we have 2 zeros because see the width of the signal here for 2 zeros. And here we have 1, and here we have 0, and here we have 1, and it continues. So we can say that this signal consists of 1 and zeros. So what is a byte? A byte is a signal that consists of 8 of these. 8 of these. Now these numbers, 1 and zeros, they are called bits. So bit is a small unit of memory that is either 1 or 0 as a signal, either 5 volt or it is 0 volt. So let's go back to the PowerPoint presentation. So a bit is a digit with a value of either 0 or 1, and a byte consists of 8 bits. So when you go inside the memory and look at the electronic circuits inside, usually the memory is divided into blocks. Each block is 1 byte, which is a signal that consists of 1 or 5 volt or 1 or 0 volt. I cannot go further in details because this is electronics. If anyone is interested to know more, just go to the internet and look for more information. For the moment, a byte is a unit that is used for measuring the capacity of a memory, and a byte consists of 8 bits, which consists of 1 and 0. So each byte in main memory resides, it means yuqim, at a numbered location. So there is a location for each byte in the memory, and this location is called address. Look at this picture. Of course, the look of the picture physically when you see it by your eyes, this is the look of the memory when you look at it by your eyes. But conceptually, how we represent it, conceptually it means if we want to deal with it without going physically, we can look at it as a block that as a table consists of blocks inside. So each block is 1 byte, see? And these blocks, the bytes are numbered. They have numbers. It's called an address. So this is the first byte, sorry. This is the second byte, this is the third byte, and etc. So every memory you have in mind consists of bytes. But how many bytes required for each data, it depends. For example, if I want to save your telephone number, and you know your telephone number consists of 8 digits in decimal, and in the memory maybe it needs 5 bytes to represent your mobile number. So 5 bytes will be allocated for the telephone number. راح ينحجز في الميموري 5 byte for your telephone number. Suppose you want to save an MP3 file, and you know that for some MP3 files there are 4 megabytes and etc. So 4 million bytes. So you need million bytes. So you need millions of these blocks for your MP3 file. Of course, for picture it takes more memory. The point here is that the memory consists of bytes, and each byte is numbered. Later we will explain to you when we define variables in memory how they look like inside the memory. So what can we store inside the memory? Any kind of data maybe numbers, maybe letters, maybe strings. Strings, it means words, and maybe audio, maybe video, and even programs. They are saved inside the memory, but they should be converted into 1 and 0. So if you want to save a picture, first you have to convert it into 1 and 0. And you don't do it yourself. It is done automatically for you. For example, if you are working on Photoshop. Now Photoshop saves the picture and load the picture in binary 1 and 0. So it reads the picture and convert it into 1 and 0s and save them in file. And once you load the picture, it reads this file as 1 and 0s and show it on the screen for you. So any data you want to save in the memory, it must be encoded, converted into 1 and 0. When more than a single byte is needed, several adjacent means ورا بعض. So إذا المعلومة تحتاج any of these data, if it needs more than 1 byte, so adjacent bytes are used. اللي هو memory blocks ورا بعض are reserved for this data. You're already familiar with files. So files and folders. So I'm just going to simply skip this slide. Machines with only 2 stable states are easy to make, but programming using only 0s and 1s. And here, when we write a program for the computer that consists of these 2 signals, the language is called machine language. So machine language is a language for the computers that consist of only 0s and 1s. But for a human, especially for ordinary people, it's difficult for them to understand this language, even for professional people. 0s and 1s are difficult to deal with, so they discuss with a little bit higher level. It's called assembly language, as I will show you an example in a moment. The encoding from any data to 1 and 0s is done automatically by programs. So fortunately, the conversion of numbers, letters, strings of characters, which are, let's say, words, audio, video, and programs, are all done automatically. I have provided here a picture for a big picture for hardware and the operating system for some machines. I have provided one for a desktop computer, which is PC, either HP or Dell or Asus or any other brand, and for a mobile iPhone X and a mobile Samsung Galaxy S10. Here I have provided the CPU for each of them, RAM, secondary memory, and the operating system for each of them. For desktop computers, of course, these are not the only CPUs for desktop computers. These are for a company called Intel. There are other CPUs for desktop PCs, but other brands like AMD, Motorola, but they are not popular like Intel. Now Intel is a popular company that they manufactures processors or CPUs for personal computers. If you want to buy a laptop or a desktop, go for these 2 processors. Don't go for less than these 2 processors. And you can find maybe most of the laptops or computers, a logo in the front of the keyboard shows you the CPU. You will find cheap laptops with i3 and maybe it says Intel, Centron or Duo. Take my advice, don't buy those computers, because when you put Windows 10 on them, and especially if you don't have a fast hard drive, then the computer will be very slow, and it cannot last longer than 1 year when a new operating system appears in the market. So go for these, and most of the touch laptops, they come with i5. But if you go for i7, then the price will go up a little bit. So go for i7 if you are if you don't want to go for a touch screen, then go for i7. The CPU for iPhone X is also developed by Apple, which is called A11 Bionic SoC. And for Samsung, before they were using third-party processors. They were not manufacturing processors, but now they have their own designed or made processors. It's called Samsung Exynos 9 Octa 9820. Of course, this is not the latest one. the latest one may be higher than this number. Now the memory inside for each computer, and this is what's important that you need to look at when you buy a computer or a mobile. Look for the size of RAM. I know secondary memory is important. This is for storage, secondary memory. You store data, you store programs. Yes, if you go for high number, it will be useful, but you can extend this. You can extend it by putting a flash memory, for example, for Galaxy, Samsung Galaxy mobiles. And for iPhones also, there are some devices where you can put a flash memory. But for RAM, it is an electronic chip. So when you buy the computer, especially mobiles, you cannot change them. For desktop, you can change them. You can extend them. But for iPhones, you have to buy a new iPhone, the latest one with higher RAM. So as when you compare these two, in terms of RAM, Samsung beats iPhone X. See, it has a very high or space of RAM. So when you put the programs inside, you will not see that the mobile is slow. But the speed of the mobile is not only determined by RAM. It is determined by the operating system, by the CPU, and etc. So when I say that RAM for Samsung is better than iPhone, doesn't mean that overall Samsung is better than iPhone. And when I say that iPhone, the processor is more faster than Samsung, doesn't mean that iPhone is better than Samsung. So it is like we say bargain between the two. For the operating system, PCs have Windows, iPhones they have iOS, Samsung they have Android, and for MacBook they have Mac iOS, and etc. Now my question is the following, and maybe I need an answer from one of you. Can I run a Windows program on iPhone? I can download it somehow on iPhone. Can I run it?
No, doctor,
Yes.
I don't think you can.
Somebody say yes, somebody say no. Let me go for another example, similar. Can I download an iPhone X application and run it on Samsung? I know you might see two versions. When you go to iPhone X, you will see the same program on what is it called? Play for Samsung. I am not familiar with Samsung. I'm familiar. Google Play. Yes. So can I just simply take a program from Google Play and run it on iPhone X?
No.
No, doctor, I don't think
The answer is no. I know you might see similar, but the answer is no. Why no?
Because the
because
program
it's incompatible.
has to convert it to the iPhone version.
And but this does not yeah, convert it. But why we need to convert it? Why we don't just take it directly and run it?
Because it's a different operating system.
Different operating system. This is one answer. Yes, correct. This is because they have different operating systems and also different CPUs. Because every CPU has its own language, machine language. So when you download an application from Google Play and run it on your Android operating system, which is Samsung, then the program will be converted into the machine language of Samsung Xeon 9 Octa 9820. If you take the same file and try to run it on iPhone A11, the CPU will not understand it. Maybe some of you familiar with the programs on Windows, they have the extension .exe. When you double click it, then it will install the program. This .exe has a machine language for Intel. So this is why when you take .exe file and try to run it on iPhone, it will not run because the machine language is different. Even the operating system will not identify it. It will say, what kind of a program is this? So this is why we cannot run programs that are written in object code, which is machine language, from one to another. So this is just, a big picture of some terminologies that most of us should be familiar with computers.